Welcome to BSc Statistics students. So in this lesson I explain one of the problem in processing of n jobs through k missions. This is the problem in sequencing problem. Processing of n jobs through k missions. We have calculated n jobs 2 missions, n jobs 3 mission problem, n jobs now k missions. Right? So there are four, we see the problem. There are 4 jobs, each of which has to go through 6 missions M1 to M6, and the processing times are given here. So 4 jobs A, B, C, D, and missions M1 to M6, the processing times are given here. Determine an optimum sequence, that is a sequence of 4 jobs which minimizes the total elapsed time. So you have to calculate total elapsed time and you have to calculate optimum sequence. What is the sequence of jobs? Right, for which what we have to do? So as per the procedure is going to be considered, you have to calculate for first mission and last mission, you have to calculate minimum processing times. So the minimum processing times I am calculating the minimum of TI1, it is equivalent to be first mission, this is M1, minimum is 13, right? Similarly, you calculate minimum of TI6 because the last mission is 6th mission. Minimum of TI6, it is 14. For remaining all, you have to calculate maximum, that is maximum of TI2, maximum of TI3, maximum of TI3, maximum of TI4, and maximum of TI5. You have to calculate for 4 missions, you have to calculate the maximum values. Maximum of TI2, it is 10. TI3, it is also 10. Right? And maximum of TI4, it is 8. And maximum of TI5, it is 12. Now you have to check the 2 particular important conditions. I check the condition here. Condition 1. Minimum of TI1, condition 1, minimum of TI1, whether it is greater than or equal to maximum of Tij, remaining all, j is equal to 2, 3, 4, 5. Okay, I specify the values. J is equal to 2, 3, 4, 5. Similarly, second one, minimum of Tik, that is 6th, last one, it is greater than or equal to maximum of Tij. What your j is equal to 2, 3, 4, 5, right? Now you say whether it is right or wrong, that is which conditions are satisfying, condition 1 or 2 or both. You see minimum of TI1 13, and TI2 10, TI3 10, 8, TI4 8, TI5 12. So it is greater than or equal to all, therefore condition 1 is satisfied. Similarly, condition 2, of course, condition 1 is minimum of TI1 is 13. TI6 is 14, therefore condition 2 is also satisfied. So therefore both the conditions are satisfied, therefore you can create 2 dummy missions G and H. You have to create 2 dummy missions G and H. So I have prepared a table here. So the missions, 2 dummy missions G and H, the processing times which are called TIG. What is the formula of TIG? I write TIG. The formula for TIG is you have to add for 5 missions TI1 plus TI2 plus TI3 plus TI4 plus TI5, and TIH, H is by leaving the first one, second to last, that is TI2 plus TI3 plus TI4 plus TI5 plus TI6. You have to add the time, that is processing times of 1 to 5, you will get the processing time of mission G, and processing, if you add processing times of 2 to 6 missions, then you will get the processing times of H mission H, right? So they are just what you have to do, which means what you have to do, you have to add like 20 plus 10 plus 9 plus 4 plus 12, that is the for job A the processing time, for dummy mission G, like that. If you add the values, you will get the values here, like the noting, you please kindly add it, and so that we will get the values like here it is 55, this is 56, and 46, 49. Hope you understand. Just you have to add the respective processing times of first mission to fifth mission. You have to add for all. That is now again for the second one. For first one 20 plus 9, 10 plus 9 plus 4 plus 12. Clear? And for that is for job B, 19 plus 8 plus 11 plus 8 plus 10. Next one 13 plus 7 plus 10 plus 7 plus 9. Next one 22 plus 6 plus 5 plus 6 plus 10. This is for, that is you have to add from mission 1 to mission 5 processing times. For G, mission H is mission 2 to mission 6, that is 10 plus 9 plus 4 plus 12 plus 27. So the for mission H it is the value is 62 for job A, and then similarly you have to add 8 plus by leaving 19, 8, 11, 8, 10, 21. You have to add the processing time. You will get the processing time 58 like that. You have to add remaining processing times for job C and job D, 50 and 41. So these are the processing times for mission G and H, so which are called dummy missions. So we have created dummy missions purely to get the purely you have to calculate the to get the optimum sequence. So I'm calculating the optimum sequence here. What is the optimum sequence? It is going to be obtained from, I'm considering the optimum sequence, right, for 4 jobs. 1, 2, 3, 4. Okay, optimum sequence. You know, you have to we know you have to apply the for the to get the optimum sequence. You have to apply the Johnson's algorithm for 2 jobs and n jobs, n jobs and 2 mission problem. Like as usual, n jobs and 2 mission problem of Johnson algorithm. Like what is the minimum processing time here in the entire G and H? It is 41. So you have to place you have the minimum processing time. It is 41. You have to place D from the last of the sequence. Clear? So this was finished. D was finished. So you should not touch these values. And then you have to consider remaining processing times and consider minimum processing time. The next minimum processing time is 46. That is corresponding to C and corresponding to the mission G. Because of mission G, you have to place it from first, that is C, and then you have to place that this is also placed, and then you have to consider A and B, the processing times of G and H of jobs A and B. The minimum processing time is 55. The 55 is of job A and mission G. You have to place after C, that is this is A. Because of the first mission, you have to place it A after C, and then of course only one particular job which is to be placed here. So the sequence, optimum sequence is obtained. This is what the optimum sequence, C, A, B, D. That is what we have to consider here in this and the table. In this particular table, I have prepared the table to calculate the timings and timeouts, for each and every mission. So in this the sequence, optimum sequence of the jobs are prepared here just now. That is C, A, B, D. This is the order or the sequence of the jobs which are to be done through the missions, through all the missions, for all the missions, mission 1 to mission 6. So this is what the optimum sequence you have obtained, and by taking this particular optimum sequence in the calculation of the times, that is time in and time out, that total elapsed and then total elapsed time to calculate the total elapsed time, you have to consider this optimum sequence. Is it clear? Because of the optimum sequence we have calculated for 2 mission problem, we have converted first of all the given problem of 6 mission problem and 6 mission problem we have converted into 2 mission problem. N jobs 2 mission problem, N jobs K mission problem we have converted into N jobs 2 mission problem, and then we have find out optimum sequence. That is, this is what the optimum sequence by using the n jobs 2 mission problem. And then we have considered the optimum sequence here to calculate the total elapsed time and all time ins and timeouts of the each and every mission. Clear? Now I start the calculation for the time in and time out. That is, as usual, what you have to consider is you have to consider the original table again. This is what the table. This is what the table process of processing times. You have to consider these processing times and then you have to calculate it. Right. So therefore, now I consider the value, and so that I do the values here. For first time in for first mission, it is 0. 0 plus processing time of mission 1 of job processing time of job C on mission 1. You see, this is the table it is going to be considered. For C it is 13. Okay, so therefore 0 plus 13, 0 plus processing time 13, it is 13 timeout. 13 it is going to be time in for the next job A. On mission 1 for job A processing time is 20. So 13 plus 20, it is 33. Okay, 33. And time in for that is next job, it is 33. And timeout, that is processing this plus processing time of job B processing time on mission 1 is 19. 33 plus 19, it is 52. 52 is the processing time you have to consider for the time in for the next job D. So 52 plus the processing time of job D of mission 1, it is 22. Is it clear? 52 plus 22, it is 74. So now this is what time in and time out for mission 1. Now come to the mission 2. Time in and time out. So you have to consider all the processing times of mission 2 of the jobs respectively C, A, B, D. Now time out for the first job, that is job C for mission 1, it is nothing but time in for mission 2, it is 13. Now plus the processing time for the job C on mission 2. Now you have to consider these mission 2 processing times 10, 8, 7, 6. Of job C it is 7. So therefore this plus processing time 13 plus processing time 7, it is 20 timeout. Now you have to go and see, you have to observe clearly the processing times of, is it clear? 1 minute, yes. So 20 and 33, you see, this is the timeout for the first, that is the job C, the first job on mission 2. But if you go to the time in calculation of time in for the mission 2, it is to be observed the second job when it is timeout of on second job on mission 1. The second job is A. It is timeout for the job A is 33 on mission 1. So 20 is timeout. You have to consider maximum among 20 and 33. That is only the logic you have to consider. You have to remember. So the maximum value is 33. Therefore 33 is the time in for the next job. That is, the next job is A and the processing time of mission 2 is 10. So 33 plus 10. 33 plus 10, it is 43. Now 43 and 52, the maximum is 52. Maximum is 52. 52, this is of job B. You go and refer job B. The processing time on mission 2, it is 8. 52 plus 8. Now 52 plus 8, it is 60. And 60 and 74, the maximum is 74. Okay, and 74 and plus the processing time of job D on mission 2. You refer, this is of mission 2, job D is 6. So therefore 74 plus 6, it is 80. Now and again you have to come to the mission. Now then you have to calculate the processing times, the time ins and time outs of mission 3. What is the time in for first job? The time out of first job on mission 2, it is nothing but time in for the first job for mission 3. It is 20. Time out of the previous job, that is the first job. The first job, that is job C in mission 2, it is 20, and it is the time in for mission 3, third mission. So up to 20 hours, let it be 20 hours. The mission 3 has to wait for 20 hours to start job 1, that is C. Right? And then you have to consider, you have to add, that is the processing time of C on mission 3, then 20 plus processing time, the mission C. These are the processing times of mission 3. The processing time of mission 3 on for job C, it is 10. So 20 plus 10, it is 30. Is it clear? Right. 20 plus 10, it is 30. And 30 and 43, the maximum value, it is 43. Hope you have observed, but it was finished by that is 30 hours, after 30 hours. But that next job, it is not finished in mission 2 by 30 hours. It is to be completed. It will be completed in 43 hours. Therefore, this mission has to wait for more than 30 hours. That is 13 hours. The mission 3 has to wait to do the next job. That is the meaning. So therefore, now we have to add the processing time of job A on mission 3, and mission 3 and job A. Job A processing time on mission 3 is 9 hours. Therefore, 43 plus 9, it is 52. And 52 and maximum of 52 and 60, it is 60. And 60 plus the processing time of job B on mission 3, it is job B, it is 11. So 60 plus 11, it is 71. 71, maximum of 71 and 80, it is 80. So 80 plus processing time of job D on mission 3, it is 5. So 80 plus 5, it is 85. Clear? 85. Now coming to the mission 4. Mission 4, the time in for first job, it is time out for the first job on mission 3. So hence it is 30. 30 plus processing time of job C. So these are the processing times of mission 4. Job C, it is 7. So 30 plus 7, it is 37. Clear? 30 plus 7, it is 37. Now time out of previous mission, that is the previous mission of job mission 4, and next job of mission 3, that is we have to consider maximum 37, maximum of 37 and 52, it is 52 plus the processing time of job A on mission 4. Job A on mission 4 is 4. 52 plus 4, it is 56. And maximum of 56 and 71, it is 71. And for job B, the processing time on mission 4, job B, it is 8. It is 8. Therefore 71 plus 8, it is 79. 79. Maximum of 79 and 85, it is 85. 85 plus processing time of job D on mission 4, it is 6. Clear? It is 6. So 85 plus 6, it is 91. Clear? Mission 4 finished. Next mission 5. The time in for the first job is time out of first job on mission 4. It is 37. So that is 37 is time in for first job, that is job C. And if job C processing time on mission 5, the mission 5 processing times are here. 12, 10, 9, 10. Job C, 9. So 37 plus 9. Is it clear? 37 plus 9. It is 46. The maximum of 46 and 56. It is 56. 56 plus processing time of job A on mission 5. Job A, it is 12. So 56 plus 12. It is 68. And 68, maximum of 68 and 79. 79. 79 plus processing time of job B on mission 5. Job B on mission 5, it is 10. So 79 plus 10, it is 89. 89 and 91 maximum, that 91. 91 plus the processing time of job D, it is 10. So 91 plus 10, it is 101. So which are the timings and timeouts of mission 5. Coming to mission 6. Mission 6, the first one, timing is 46. Timeout of the mission 5 of job C, that is first job, 46. 46 plus processing time of job C. Job C, the processing time, last mission M6. Job C, it is 17. 46 plus 17, it is 63. 63. Maximum of 68 and 63. 68. For job A, the processing time 68 plus the processing time of job A, 27. Clear? 68 plus 27, it is 95. 95. Maximum of 89 and 95. Now 95. It is 95. Maximum. 95 plus processing time of job B. Job B. That is next job on mission 6. Job B is 21. 95 plus 21. It is 116. 101 and 116. Maximum 116. Plus the processing time of job D on mission 6. That is 14. So you have to consider it is 114 plus 116. That is 130. So total elapsed time is of this particular problem is 130. The optimum sequence is 2 questions you have to answer. First question, the optimum sequence is for the given problem is I am drawing a particular a kind of table CABD. This is optimum sequence, and total second bit total elapsed time. Total elapsed time, it is equivalent to be 130 hours or whatever it is specified time period. So I am considering 130 hours. So this is what the problem of processing n jobs and through k mission or n jobs and k mission problem in the sequencing problem, right? This is the way you have to calculate the problem, right? Fine. Thank you very much.